Okay, the first two of this section were fairly straightforward. Negative 1.24, we read that out as negative 1 and 24 hundredths, which can simplify. Both of these can be divided by 4, so we get 6 on the top, 25 on the bottom, and we just want to bring over our whole number. So it's negative 1 and 6/25. For part B, 49 fiftieths, we probably would be best off thinking this in terms of hundredths as well. I multiply by 2 in the bottom, multiply by 2 in the top. 49 times 2 is 98. So 98 hundredths is the same thing as 0.98. So far so good, and then we get to this repeating decimal one. So this is the trick that we learned fairly recently. We're going to let x equal the number, and I'm just going to kind of write it out maybe just a few times to get the hang of what's going on here. We have 0.24, 24, 24, on and on and on. We count the number of digits that repeat. So since there are 2 digits that repeat, I'm going to multiply by 10 to the second power, or 100. Another way to think about it is the number of digits that repeat are the number of zeros that you're multiplying by. So when I do that, I bump the decimal over twice. So I line up my decimal, I have 24 point, and then I still have all this mumbo jumbo here, 24, 24, 24, on and on and on. Okay, now I'm just going to subtract these two. All right, 100x minus an x is 99x. And then this is the fun part. All of this stuff goes away, right? So the only thing I'm left with over here is 24. So now, in order to get x by itself, I'm going to divide by 99 on both sides. And when I do that, I am left with a fraction 24 over 99. And these have a common factor. This is, excuse me, why we use those divisibility rules. We know that if you add up the digits, they both wind up being divisible by 3. So when we do that, 24 divided by 3 is 8, and 99 divided by 3 is 33. And now it's really cool is we can actually check to make sure that it works. So 8 divided by 33, when I hit enter, look what I get, 0.24, 24, 24, 24, and on and on and on and on. So we've done it right.